Kira is given an angle of 220 degrees from the initial side that is the positive x-axis. What is the tangent ratio corresponding to this angle, and is it positive or negative? Recall the cast rule. We need to draw out our 220 degree angle first, and then we have to determine if the ratio will be positive or negative depending on the quadrant that it is in. Recall that in the first quadrant, all of the functions are positive. In the second quadrant, only sine is positive. In the third, only tangent is positive. And in the fourth, only cosine is positive. Let us first take out our protractor and try and determine where our 220 degree angle will be. So here we have 180 degrees that is already covered, but we still need a little bit more, and we see that the terminal arm will probably lie in the third quadrant. So what we need to do is determine how much further, how much more degrees from the negative x-axis we need to draw. So we minus 180 degrees from 220 degrees, and we get that we still need to have 40 degrees below the negative x-axis. And we see that if we minus 40 degrees from 90 degrees, our terminal arm will lie where this 50 degree angle is. And so we draw our terminal arm, and we have our 220 degree angle. So we see that this angle is in the third quadrant, and from cast we know that it is positive, and if we calculate the ratio, it is approximately 0.8391. In the next lesson, we will be going over how to find exact numbers of these ratios, but for now we can just round. Franklin is told to draw an angle that produces a negative cosine ratio and a negative tangent ratio. What are the least and greatest angles that Franklin can draw? Express your answer in degrees and radians. Recall the cast rule again, and we need to find the quadrant where both cosine and tangent are negative. So we know that cosine is negative in the second quadrant and in the third quadrant. And we know from cast that tangent is positive in the third quadrant. And so the only quadrant that is left is the second quadrant, and so we know that the angles have to lie in this quadrant. So we have our second quadrant, and first let us determine the smallest angle. We will count from our 90 degree angle. In the next lesson, we will know for sure that cosine isn't positive or negative, and so we draw the closest whole number degree angle in the second quadrant from 90 degrees. What we have to do is add 1 degree to 90 degrees, and this will give us 91 degrees. And so we have our smallest angle right here. And for our biggest angle, we need to draw an angle going from the 180 degree line into the second quadrant. If we take away 1 from 180 degrees, we get 179 degrees to be the greatest angle. The last thing that we have to do here is convert from degrees to radians. Recall our formula. If you want to recap on this, you can go to our previous lesson. And so all we have to do to determine the radians of 91 degrees and 179 degrees is simply to multiply the right hand side by 91 degrees and by 179 degrees. So 91 degrees converts to 91 pi over 180 rad, and 179 degrees converts to 179 pi over 180 rad. These fractions cannot be reduced any further, and so we have our final answer. The smallest angle that Franklin can draw is 91 degrees, or 91 pi over 180 rad, and the largest angle that Franklin can draw is 179 degrees, or 179 pi over 180 rad.